let's go to start talking about memories. We kind of talked about cache, introduced already. Small memory, but very fast, local. So it's nearby, it's small, and even the technology is such that this is very fast access. So it tends to store something that we will see there is various policy, but something that was used recently. It's kind of like a small short-sighted memory. And it's something that is needed often. So the hypothesis here is that something that was used recently is going to be used again. It's going to be re-referenced by the software. The division between cache versus main memory is completely transparent to the software engineer, to the programmer. So the programmer doesn't know. Well, so the best programmers that do high performance computing better know how much data fits in cache and how to handle it. But in general, it's not something software designers could worry about. This is completely handled by the hardware. Everything is transparent. If the data is not in cache, it will be retrieved. It will be a small penalty in the performance, but also the managing of the cache. There's very sophisticated algorithms in hardware that try to minimize the penalty. Cache memory, typically, certainly level 1 cache, that's extremely small and fast. This is usually embedded on the CPU, very close by. Let's say in the order of 2 clock cycles to get data from there. Then we have level 2 cache. That's the next level away. It's a little bit bigger, a little bit slower. Now we are in the terms of 10 clock cycles to get the data from there. So every time you miss in cache, you go in level 2 to see if the data is there. That's what the algorithm does. Nowadays, it's typically located on the CPU as well. Sometimes a separate chip is required, but this is more in the old days. Main memory is hundreds of clock cycles away, so that's the penalty if you miss in level 1 and in level 2. That's the penalty to go retrieve a chunk of data. But one of the points is that once you miss, the protocol, the managing here in the hardware will retrieve a big chunk of data that is close to each other, and so that will basically likely not miss again for a little while. At least that's the empirical evidence or the assumption that makes cache work.